Hello and welcome to our lesson on solving rational equations. This is going to be from section 5.5 in our text. First of all, you need to know what a rational equation is. Well, the way I remember this is rational rhymes with fractional. Rational equations are fractional equations where you have a variable in the denominator. I have listed the steps that I want you to go through when solving rational equations. Number one, you need to list the restrictions. That means any value that x can't be, we want to list that up front. And then we're going to go through and solve by eliminating the fractions. Then we will solve the resulting equation. And finally, once we have our solutions, we want to check those against the restrictions to see if they can be solutions. And now that the checklist is out of the way and explained, let's jump into the examples. Our first example is going to be number 3. Here we have a rational equation. We know it's a rational equation because there are fractions involved in which there is a variable in the denominator. So what we want to do first is we want to list the restrictions, and the restriction here is that a cannot be 0, because if a is 0, we'll have division by 0, which is undefined. So a cannot be 0. Now, step number 2, we're going to eliminate the fractions. And I have a particular technique for this. If you get all the denominators to match, you can cancel them out. So what we want to do is we want to go through and give each denominator what he needs so that they all have the same stuff. So I'm looking at 4 and 6, and I'm trying to think, okay, what can I give each one of those so that they would be the same? And I'm thinking a 3 and a 2. Okay, now check that out. 3 times 4 is 12. 2 times 6 is 12. So if I give the 4 and the 6 a 3 and a 2, they'll both make 12. Now, whatever I do to the bottom, I have to do to the top. So the 1 needs a 3, and the 5 needs a 2. And then if I look at this last denominator, I can see that he has an A. So what he's going to need is a 12, so that now they all have 12. But look at the first two denominators, they don't have the A. So I'm going to have to go back and give them an A. Of course, I got to give it to the top also. All right, so if you are following along with what I've done, I went to each denominator and I multiplied by whatever they needed so that they now all have the same stuff. Okay, notice this. 3 times 4, that's 12a. 2 times 6 is 12a. 12a. Do you see they all now have a 12a in the denominator? And once they all match, you can cancel them out. And whatever is left in the numerator is going to be your resulting equation. So we're going to have 3a minus 10a equals 12, and then I can just solve for a. 3 minus 10 is negative 7a. Then if I divide both sides by negative 7, this is not going to divide nicely. In fact, it's improper, but that's the way I like it. So we're going to leave it negative 12 sevenths. And then we're going to check that result against our restriction, okay? If this answer was 0, then that would really not be an answer. But it's negative 12 sevenths, which does not violate the restriction. So negative 12 sevenths is the answer. And that's it for the first example. All right, the next example we're going to look at here is number 10. Again, this is a rational equation because we have fractions with variables in the denominator. And the first thing we need to do is list the restrictions. So in this rational equation, the only thing y cannot be is 0, because if I plug in a 0, either one of these places, that'll give me a denominator of 0, which division by 0 is undefined. And any other number that I plug in for either one of those denominators is not going to make a 0. So this is the only restriction. Now I can go through and solve the equation. So we're going to eliminate the fractions by giving each denominator what they need so that we can cancel them out. The first denominator has a 3 and a y, factors of 3 and y. The second denominator needs the 3. Whatever I do to the bottom, I have to do to the top. So now he has a 3y. And the last denominator needs the y. So I have to give it to the top. And now do you see that all three denominators have the same stuff? And I can cancel them out. So that'll leave me with 4 minus 9 equals 10y. And then I can solve. So the next step is we're going to combine like terms. 4 minus 9 is negative 5. And then I need to divide by the coefficient of the variable. We're going to divide both sides by 10. And you do need to reduce to lowest terms. Negative 5/10 reduces to negative 1/2. That does not violate the restriction. So this indeed is the solution. Next, number 13. In this example, we have a special type of rational equation. Okay, so you need to know that when you have a single fraction equal a single fraction, that's called a proportion. And when you have a proportion, there is a fast and easy way to solve. To solve a proportion, you simply cross multiply. And it doesn't matter which way you go first. Okay, so I'll demonstrate. Let's say that we want to go using the 2 first. 2 times y plus 1 will equal 3 times y plus 3. Now notice doing the cross multiply, what that does for us is it gets rid of the fractions. That is a fast and easy way to eliminate the fractions. If you can recognize when you've got a proportion, you simply cross multiply to get rid of the fractions. So next, with the distributive property, we're going to have 2y plus 2 equals 3y plus 9. Next, what I'm going to do is I'm going to bring the 2y this way and the 9 back. So the plus 9 will make negative 9. The plus 2 comes down. The 3y comes down. And the 2y becomes negative. And then all I need to do is CLT and I'm done. Negative 9 plus 2 is negative 7. 3 minus 2 is 1. Y, which is just y. And darn it, if I didn't skip step number 1. Step number 1, identify the restrictions. So let's go ahead and you know what the nice thing about the checklist is, it doesn't matter if you list the restrictions first or last, as long as you remember to check them when you're done. So what are my restrictions this time? For number 13, I can see this denominator has a y plus 1. So y cannot be negative 1, right? Negative 1 plus 1 would make 0. The denominator can't be 0. And for the second denominator, y cannot be negative 3. Because negative 3 plus 3 would make 0, and the denominator cannot be 0. And now if we check, our solution does not violate the restrictions. That means it doesn't equal one of the restrictions. And therefore, negative 7 is a valid solution. checking the restrictions, all that does is verify that this could be the answer. It doesn't really verify that it is the exact answer. So if you want to check and make sure that it is absolutely correct, you really need to plug that back in and check it. So doing that would give me 3 over negative 7 plus 1 equals 2 over negative 7 plus 3. And if that's really the solution, I should have equality. So in the denominator, negative 7 plus 1 is negative 6. 3 over negative 6 is negative half. For the other fraction, negative 7 plus 3 is negative 4. And 2 over negative 4 is negative half. And so that verifies that negative 7 is absolutely correct for this equation. Next, for number 19, we have another rational equation, and I promise I won't skip the first step this time. X cannot be 0 seems to be the only restriction because there are only two fractions with variables in the denominator, and both of those would be made 0 if I let x be 0. So 0 is the only restriction. Now I can proceed to solve the equation. So I'm going to keep using my same technique. I'm going to get all the denominators to match, and then I can cancel them out. I'm thinking that this 2 needs a 9 and an x, and altogether that would make 18x. So if you're not sure where I got that from, I took a look at the other denominators and I estimated what I could turn them all into. I think I can turn them all into 18x, and so that's why I chose the 9 and the x. But remember, whatever you do to the bottom, you have to do the top. Don't forget that. Next, 9 times 2 would give me 18x. That already has the x, so the 4 gets a 2. The next fraction, 9 times 2, and he needs the x. So the 4 gets the 2 and the x. And now 6 times 3 is 18. He already has the x, so all he needs is the 3. Okay, now look what I've done. 2 times 9, that's 18x. 18x. 3 times 6, 18x. If you can get all the denominators to match, then you can cancel them out, and whatever's left in the numerator is your new equation. So we're going to have 9x minus 8 equals 8x minus 3. And these signs here are important. These, if you're going, how did I get those minus signs? That's where those came from. I think we're just one step away from solving, bringing the 8x over, bringing the negative 8 back. That's going to give me 9x minus 8x equals 8 minus 3 CLT. 9 minus 8 is 1. That's just x. 8 minus 3 is 5. And it looks like our solution here is 5. And that, again, that does not violate the restriction, so that is going to be a valid solution. And again, if I wanted to check and make sure it's absolutely correct, I would need to plug it back in and check it. And I'm not going to do that this time. I will leave that for you as an exercise if you want to go back and check it. Remember, to check this, you would have to plug it back into the original equation for every x and check for equality. Next, number 21. Here we have another rational equation, and I am so tickled to death to have this particular equation come up because it lets me illustrate an important point that you may have assumed up to this point, but I want to make sure you completely understand what I mean when I say get all of the denominators to match, and then you can cancel them out. Okay, some people are going to look at this and say, okay, If I want the denominators to match, I'll just put a minus 5 on each one of these, and then they all say x minus 5. Okay? That's illegal. That is breaking the laws of math, because the only thing that you can do to a fraction to keep it an equivalent fraction is multiply. You can't say, well, I'm going to minus 5 to the top and bottom. That won't give you an equivalent fraction. You're going to have to use factors when you come up with your common denominator, when you get them all to match. So you're going to have to look at this x minus 5 as a single thing. You can't break it up and look at the x and the minus 5 separately. X minus 5 is a single expression. And then these x's, they're their own separate expression. Okay, I hope I got my point across. Now, if I want to make all of these denominators match, what I'm going to have to do for the first denominator is give him the x minus 5. I have to look at this x minus 5 as a whole expression. And the first denominator did not have an x minus 5, so he needs one. But whatever I do to the bottom, I have to do to the top. He gets x minus 5 multiplied by the 60. Looking at the last denominator, he also needs the x minus 5. Now, let's take a look at the middle denominator. What does he need now that the other two have? Well, he needs an x. He needs a factor of x. And so whatever I do to the bottom, I got to do to the top. And now, does every denominator have the same stuff? In other words, are they identical expressions now? They all have an x times x minus 5. And so since they're all the same, I can now cancel them out. And then I'm actually going to have to do the distributive property to get my new equation. Okay, so here we go. 60 times x, that's going to give me 60x minus 60 times 5, that's 300, minus 60x equals 2x minus 10. Doing the distributive property at the back. And now I've got a new equation that I can solve for x. This is going to go quickly now. 60x minus 60x, those cancel. Minus 300 comes down. And in the next step, I'm going to bring my minus 10 over. That makes it a positive 10. What is 10 minus 300? Well, that's a negative 290. And last but not least, if I divide both sides by 2, that should give me my answer. Negative 145. And let's put a box around that because we're done. OMG. I just noticed I forgot to do step number 1 again. Holy cow. Okay. So let's go ahead and list the restrictions and see if this answer violates any of the restrictions. In the original equation, since I had x's alone, I know that x cannot be 0 because plugging that in to either one of those denominators would make 0. And I can see that x cannot be positive 5 because if I plug it into the middle denominator, 5 minus 5 is 0. And so x cannot be 5. Those are the restrictions. The answer does not violate those restrictions. And again, if you want to make sure that it's absolutely the correct answer, you would need to plug it back in and check. But I'm not going to do that. I'll leave that as an exercise for you to do if you want to plug it back in and check it. Number 27, our next rational equation has a characteristic that we've not had yet that we're going to need to address. First of all, if any of the denominators can be factored, you need to factor them so that you can find the common denominator. Notice that the first denominator is a quadratic, and not only is it a quadratic, it's also a trinomial. So how do we factor a trinomial? Well, it's a three-step process. We're going to use parentheses, we're going to read the signs, and then we're going to fill in the blanks. You always look at the last sign first. If it's a plus, you have to look at the first sign, and that's what they both are. So our signs are both going to be negative. And then the third step, fill in the blanks. What does it take to make x squared? An x times an x. For the other two blanks, I need numbers that multiply to make 3 and add to make 4. And that's going to be 3 and 1. Negative 3 times negative 1 is positive 3. Negative 3 and negative 1 is negative 4. So that is factored correctly. The middle fraction cannot be factored, so we're going to skip him. And the last denominator actually can be factored. That's a binomial, and those two terms have a common factor of 4. So for this denominator, we're going to need to factor out the 4. And that'll leave me x minus 1. And if you want to check that, you can distribute the 4 back in. You will get back what we had. And so now that is factored correctly. Everything is factored completely. Now I can make all the denominators match. So let's see what we need. Notice the last denominator has a factor of 4, and the first denominator does not, so he's going to need a 4, which the top also gets a 4. Now, if you look at the first denominator and then look at the last denominator, notice that he needs the x minus 3. And so now both of those are identical. Oh, don't forget to give it to the top. X minus 3. And now we've got the first denominator and the last denominator looking the same. Let's see if we can get the middle denominator to have the same stuff. So the x minus 3, he's going to need a 4 and the x minus 1. So his numerator gets the 4 and the x minus 1. So now every denominator has a 4 times x minus 3 times x minus 1. And now you see them? Now you don't. Our resulting equation is going to be 24. Now this minus, I'm going to go ahead and attach that to the 4. When I distribute, be very careful. This minus in front of this fraction has to distribute. So that'll be negative 4 times x makes a negative 4x. Negative 4 times negative 1 makes a plus 4. And then that's going to equal 1 times anything is itself. That's going to equal x minus 3. And now it should go pretty quickly. So here's what I'm going to do next. I'm going to take the negative 4 this way and bring the negative 3 back. That'll give me 24 plus 3 plus 4 equals x plus 4x. And then I can CLT, combine like terms. And you want to use a little TLC when you CLT. 24, 25, 26, 27, 28, 29, 30, 31. That's 31 equals 5x. Divide both sides by 5, and we're done. X is 31/5. And you know what? I'm so sorry. I forgot to do the first step again. Let's go and list the restrictions. We're going to do that from the factored form. X cannot be 3, and x cannot be 1. And again, the reason that is because if I plug in a 3 here, 3 minus 3 is 0. I can't have a 0 in the denominator. Also, if I plug in a 3 here, that would make this denominator 0. X cannot be 1 because if I plug in a 1 here, 1 minus 1 is 0, and 0 times anything is 0, so that would make the denominator 0. And this answer that we got does not violate any of the restrictions, so it is a valid solution. And if you want to check and see if it is the exact answer, like make sure you didn't screw something up, you would need to plug that back into the original problem and check it. And lastly, we're going to look at number 33. Notice in the denominators, I do have an expression that will factor. So like in the previous example, I said if any of the denominators can be factored, you need to factor them in order to find the common denominator. So here's the piece that's going to factor. This is the difference of two squares, and you need to know how to factor the difference of squares. It's a three-step process. You're going to have parentheses. Difference of squares always has different signs. And third, you're going to fill in the blanks. X and x make x squared. 1 times 1 is 1. So there's the difference of squares factored. Now I can go through and give each denominator what he needs so that they all have the same stuff. Okay, so the middle denominator has an x plus 1 and an x minus 1. The first denominator needs the x plus 1. And the last denominator needs the x minus 1. Whatever I do to the bottom, I have to do to the top. So the numerator, the 2x plus 3, is going to get multiplied by the x plus 1. And the 2x minus 3 in the last fraction is going to get multiplied by the x minus 1. And now if you notice, every denominator has the same stuff. Now you see them. Now you don't. So what are we going to have? We're going to have 2x plus 3 times x plus 1 equals 10 plus 2x minus 3 times x minus 1. And oh, are you feeling it? It's time to do the four-letter F word. Oh yeah, it's time to FOIL it. I've got a binomial times a binomial. Let's F it up. Let's FOIL it. 2x times x gives me 2x squared. On the outside, I've got a plus 2x. On the inside, I've got a plus 3x. Last but not least, I've got a plus 3. And then I would need to CLT. But on the other side, let's go ahead and F it up again. Bringing the 10 down. Here we go. First, 2x times x gives me a 2x squared. On the outside, negative 2x. On the inside, negative 3x. Last but not least, negative times a negative makes a plus 3. And now we're going to CLT. Oh, and these guys right here, the 3 and the 10. All right, let's get it all together. 2x squared plus 5x plus 3. On the other side, I've got my 2x squared minus 5x, and 10 and 3 is 13. Now, look what happens if I do this. What if I minus 2x squared from both sides? That's legal, right? Whatever I do to one side, I have to do to the other. If I minus 2x squared from both sides, those are going to cancel. So what does that leave me with? Well, now I've got 5x plus 3 equals negative 5x plus 13. And then I'm going to add 5x to both sides. Or if you think about it, I'm just going to bring this negative 5x this way and bring the 3 back. Now this guy's going to drop down and give me 5x. Negative 5x becomes plus 5x. And those are not going to cancel. Those are going to combine. Equals negative 3 plus 13. Those are going to combine. That's going to give me 10x equals 10. And now for the final step. Divide both sides by 10. X is equal to 1. And did I forget to write my restrictions again? I am so terrible. I forgot to list my restrictions again. Let's do it. So, looking at the first denominator, we see that x cannot be 1 because 1 minus 1 is 0. Looking at the last denominator, we see that x cannot be negative 1. Negative 1 plus 1 is 0. And if you look at the middle denominator, that actually accounts for both of these already. 1 squared is 1, 1 minus 1 is 0. But negative 1 squared is also 1, 1 minus 1 is 0. So that just reiterates that x cannot be negative 1 or 1. Uh-oh, but my answer was 1. Uh-oh, but 1 is a restriction. X cannot be 1. So you know what that means? It means that this is not a valid solution. And there are no other choices. So here the answer is no solution. I'm sorry, if you get an answer that violates your restrictions, you actually have no answer. So that problem is a no solution. And I did want to do one of those to show you how you can sometimes end up with no solution. And that's going to do it for this lesson. So if you have any questions or comments about anything that I've covered, feel free to leave those in the comment section below, or you can text me. And thanks for watching.